Hello everyone, my name is Krishna Singh and I am a software consultant here in Naldis. This is the second part of our series where we are going to build a decentralized application using Substrate Framework. First part was delivered by my colleague Ayush Kumar Mishra. If you watch that part then that's well and good, and if you didn't then don't worry, I will give you a quick recap. So what is Substrate? The Substrate is a modular framework that enables you to create a purpose-built blockchain by composing custom or pre-built components. It gives you a lot of exciting features and pre-built libraries to bring your blockchain idea into existence. Before we proceed, let me introduce my organization. Naldis is a team of passionate technologists with a product mindset who works along with the businesses to deliver solutions at the speed of competitive advantage. Our main capabilities are around reactive products, IoT, blockchain, microservices and API, data science, data engineering, and DevOps. We also have our strategic partnership with Databricks, Lightbend, Confluent, and many more to deliver more values to the client. Without any further delay, let's take a look at our agenda, which we will be covering in today's session. We are going to start with a recap where we are going to do a quick revision of what we did in the part 1. Then we are going to talk about how to install pallet into the runtime. I will talk about pallet more during the recap. Then we will explore about RPCs and API and how to use them to read from a blockchain storage. Then we are going to talk about light lines. Now let's begin with the recap. Let me show you the palette which we designed in a previous webinar. So idea is like, if you want to check the product you have fake or original, you can go to the product's website and scan the barcode, and it will send a query to our blockchain node where manufacturers store details about the original product and will tell you whether the product is fake or not. Let me show you the template from which we created our palette. Palette template substrate. So you can use this template to create your own palette. They also provided documentation and explanation as well if you want to know how things work here. So in high level, palette are broken into 3 sections: imports, configuration, storage, elements, error, and callable functions. So these all are the imports, and this is the configuration of our palette. This is the declaration storage. Basically, this is this map which we are going to store in our blockchain. So it's a map, as you can see. The key is a barcode, and the structure is a product of. So basically, product is a structure where we are storing ID, name, and the manufacturer. These are the events. These are the errors. And under the declaration module, we have the dispatchable function add product. So whenever manufacturer wants to add a product into blockchain, so they are going to call this dispatchable function add product. Then we are going to check, we are going to verify that the sender is a manufacturer, and if it's not, then it will throw an error that the sender is not a manufacturer. Then we are going to see a detail, if that product already exists in the storage or not. If it exists, then it will throw an error. Barcode already exists. If it's not, then it's going to register a new product and insert in the blockchain storage, and then it will deposit a event or emit event, product information stored. Okay, now let's move to our next section. So now let's install a pallet into runtime. So this is the directory structure of a node template. So to add template, we are going to make changes under runtime, that is in the cargo.toml and the lib.rs. Now first we have to implement our pallet in runtime. Basically runtime stores the business logic of our chain. So this is a node template. You can download the node template from GitHub repository. So just search node template substrate. So you can use this template to create a node. Okay, so first we are going to add the dependency under the runtime cargo.toml. So as you can see, I already added the dependency substrate barcode scanner pallet. Now I'm going to implement our pallet for the runtime. So parameter types. So basically this is a macro where you can define the constant. So basically here you can store the account ID. Now let's implement the substrate barcode scanner pallet for our runtime. Let's pick name from here. Create for runtime. Type event equal to event. Type manufacturer and copy it from here equal to manufacturer account ID. After this we also have to add our pallet into construct runtime. So we can do it from here. As you can see, I already added it, so I just named it demo pallet for now, and here I added our pallet, and that's done. One more thing, if you want to add something in a Genesis block, then you can also do that you can add it into the chain spec.rs. So basically whatever you want to add in Genesis, so you can add that thing here. Okay, that's it. Now let's move to our next slide. So the runtime contains the business logic of the chain. It defines what transactions are valid and invalid and determines how the chain state change in response to the transactions. The runtime is compiled to WESP to facilitate the runtime upgrades. And by creating runtime API, you can interact with the blockchain storage by making RPC calls. So let's see how to do that. First, let's add a helper function in our pallet. So you can do it from here. Implement the trait module public function is valid barcode hash full sorry, yeah, that's fine. Product information contains key so if blockchain storage contains that barcode, then it will return true, otherwise false. Okay, now let's create an API. So this is a macro provided by Substrate. So under this we can provide our API. First, let's declare our trait, public trait storage API function get product info barcode S256. We use it for hash. It will return bull. Okay. Now let's move to our RPC. Okay, so let's declare our trait, public trait storage API block hash it will derive RPC. Now let's declare a function get product info self at option block hash then barcode. then bool. Now let's add the RPC name. Okay, now let's declare a structure storage. Client marker phantom data Now let's implement the storage. For storage C, block, where block T C send sync static C provided runtime API block and C header backend block C API storage or runtime API block now we also have to implement members where at is of type option block hash and barcode is of type H256 Now let's implement it. Let API equal to self dot client dot runtime API. Let add equal to block ID hash self dot client dot info dot best hash. Now let runtime API result equal to API not get product info. What it will do, it will call our API at trading barcode and dot PWR convert to RPC error E. So yeah, that's it. If you are confused with the syntax, then I will provide you the reference from where you can refer it. Now let's add it in our runtime as well. Now let's implement it for our runtime. Implement runtime API storage API block for runtime get function get product info argument barcode of type S256 bool subs trait barcode scanner pallet. So basically we are calling the helper function get product info, and in this I'm going to provide the barcode. Okay, so that's it. So that's how we implemented API in RPC for our pallet. Now let's move to our next slide, light lines. So basically, light lines help us to interact with the blockchain in secure and decentralized manner without having sync the full blockchain. Basically, it offers few benefits, like a light line does not have to read or write a lot of information on the blockchain. So you can directly interact with the full node instead of the blockchain, and it requires fewer resources and storage compared to the entire node. And Parity provides a lot of libraries, so using which you can create a light line. One which commonly used is polka.js. So if you are creating something for production, then I think so you should use this, but there are all other libraries as well, so you can use that as well. Okay. And these are the references from where I prepared my presentation. Before saying goodbye, I just want to update you that you can also subscribe to our newsletter Rust Times to get an overview of the most popular Rust articles, jobs, events and news. It's a bi-weekly newsletter of trending Rust articles, events, jobs and releases. To stay updated with Rust insights, you can subscribe to our Rust Times at rusttimes.com. Thank you for attending the session. You can send me an email. Here's my email ID and the Twitter name and my LinkedIn profile. Thank you.